Oh, hey, how are you? Hey. We think so. We're just waiting for this to well, you know, we just decided to take up the thing. Yeah, it should be good. Okay. Yeah. Not that we're aware of.
I like it when that's the answer.
Definitely shouldn't be the case.
That's always a good thing.
Yeah, exactly. All right, great. And you know Leandro, yeah?
I'm sure we've met, actually.
Hi.
I'm sure we have. I can't remember.
Hi. Sorry, Leandro.
Nice to meet you.
Thank you.
I haven't had much coordinating, but thank you for chairing. This is the harder job.
It sounds very fun.
It's
I
fun.
hope so, yeah. We like to make it fun. I'm sure
See, there's a session just after this intro.
yeah, it's just the next, the open meeting.
Yeah, we will be there.
Do you have Jabber out?
Well, it's connected to the Etherpad, but yeah. But I don't have a Java. Well, I have a Java account, so but I'm not sure if it's going to work.
Hi. No, there you go. That was probably me. Thank you. Will you be able to see the screen?
Yes. This should be your
Good afternoon, everyone. Thank you for coming. This is Gaia, and I'm Jane, and this is Leandro.
Hi.
You can follow along online with the agenda. First up, for every meeting here at the IETF is that the blue sheets are circulating. Please sign in. And that we have to remind you of the note well. You can take a look online. I've been told that I don't have to go through the whole thing. So it's up to you to take a look, but you should know this by now. First up for our meeting, I'm going to turn it over to Leandro to do a quick intro. This group was started many years ago to take a look at connectivity in hard-to-reach places, underserved areas, places where, at least 49% of the population of the planet are not connected. So we bring in different experts to talk about ways to look at building anything from community networks to internet exchange points, local wireless, Wi-Fi mesh, whatever works. And some of the people in the room here are participate in Battle Mesh, where they hack mesh standards. They've deployed community networks, which are both wireless Wi-Fi and fiber, which is GWiFi, which is the network that Leandro works with. We also have with us today people from RIPE NCC to talk about what they're doing to help communities of interest with network operator groups. We have a colleague from a tribal community here in the United States that works with 19 different indigenous tribes, looking at connectivity and how to create sustainable networks that are more community built rather than last mile. So I'm going to turn to Leandro for a sec for a bit more of an introduction while we get people queued up.
Well, hi everyone. There are several housekeeping things. One is, there are remote participants today. There is the if you look in the agenda, you will see there is one link to Etherpad where we collect notes. So you're very welcome to go there and to contribute text. We try to collect a summary of the discussion over there. I will be there taking notes, but anyone else is welcome. There's also a Jabber group. You can also join, and either through Meetecho or through some XMPP client. People can also ask questions over there. And then just going directly to the introduction, there's so many screens in our table. So the slides are there. You will be able to download them later on. And the objective of the introduction is just to give a bit of context for those who are new to the group. This comes from the webpage from the group in the IETF.org website. And well, it says that this started in 2012, looking at the access gap and ways to deal with that. So maybe you can move. And then this is a list of objectives that because sometimes you forget about as we share information, as we have presentations, we can forget about why we started and what were the aims. So as you can see, it's about increased visibility and interest. So one of the aims of this working group is to share, to make visible different initiatives, very diverse, but very probably complementary. How to create together a vision that involves many stakeholders. How to articulate and foster collaboration among them, including the different aspects which have to do with what IETF does. Also the research part, what IETF does, and also what every one of you do in your own context and community. Another part is documenting and sharing information, either as experiences or as research results. Very important, sustainability is about documenting different aspects which are critical for addressing the unconnected or improving the connectivity for those who are connected. And then to look at how the research part that we do can translate into the efforts that IETF does in general. So this is the list of objectives. And then to contribute to that today, this is the agenda. So without much ado, we will start with the first presentation from the remote presentation from RIPE NCC. There was already one introductory or previous presentation in a previous GAIA session. So let's see if Miriam is ready to join.
I'm here.
Great.
Awesome.
Does it work? Can you hear me?
Yeah, perfectly.
Perfect. Thanks. Well, thanks for having me. Last time I was actually there in person, and I remember I was one of the few people who didn't present remotely. So now this time I'm also going to present remotely from tropical Amsterdam at the moment. And I'll tell you to change the slides, right? Is that how it works?
Yes.
Okay, please go ahead. Yeah, so for those of you who don't know, the RIPE NCC is mostly known for its task as a regional internet registry where we are distributing IP addresses and AS numbers. And we are located in Amsterdam. This big building there is not our office, it's Central Station, but we're located right next to it. Beautifully central Amsterdam. We have more than 20,000 members now, which is mostly because we're running out of IPv4 and everybody's trying to get the last blocks of V4 still. But we're doing many other activities. And last time I presented, maybe you can go to the next. And last time I presented mostly on our data and tools that we provide. As a regional registry, we have a lot of data that we collect from our members as part of the IP registry that we run and maintain and operate. And with that, we also offer a lot of tools, for instance, like RIPE-STAT or IPv6 measurements or routing measurements. That we make available to everybody. And we also have another measurements platform that some of you might know. It's called RIPE Atlas. Many of you actually help distributing these probes and make the network work better, because the more probes we have, the better. I'm sure there are a couple of ambassadors running around the IETF also trying to hand out probes. And all of this is described also on the RIPE Labs platform. Oh, I have a big echo at the moment now, out of a sudden. Last time I also mentioned the routing information service, which is kind of a collector of a collection of route collectors that we collect the data and make available. And last time I was mentioning a new service we had. It's called RIS Live Stream, where you can basically follow route changes live in a certain tool. So if you're interested in any of this, I'm not going to talk about that now. That was all last time. You can look at the slides from last time. This time, you can move on, please. This time, I'm going to talk more about what we do for other services that we provide to the community. Next slide, please. Where it's a bit of a mixed bag now of various community projects that we run and basically supporting various parts of the community. The first one is for network operators groups. And Jane said in her introduction that obviously one of our main communities and also most of our members are network operators in some form or fashion. I mean, it can also be enterprises or government networks, but mostly people who run networks. And so more and more over the last few years, and you all probably know this, there's an increasing number of more local network operators groups all over the world. It's almost like a natural evolution that kind of started with maybe the regional NOGs, such as RIPE and AFNOG and LACNOG and LAC. What's that called? It's called VOLC. I don't know. There's another word in Latin America. And also we have RIPE in Europe, NANOG in the US. So now we have a wealth of more localized and maybe national network operators groups. Sometimes even city groups like meetups and such. And so we thought, wouldn't it be nice to have one site where all this information is collected? So we created a map. You can see there a screenshot, and if you hover over that, there's a link at the bottom. If you hover over the link, you can see the information of that. Well, not on the screen right now, but when you go to that website, you'll see a link to that particular network operators group, and then you can find information about the next meeting, where they are, how you can contact them, and I'm some people use this to find their local NOG, and then you can start participate. On that same page, there's also a whole list of these groups, and it's not only, as you can see, it's not restricted to the RIPE service region. It's it lists all of the NOGs that we are aware of. So if there are any more, then please contact me and let us know. If you can go to the next slide. There are a number of things that we can do for network operators group, because they're kind of close to our heart. They're almost like little mini RIPE meetings, and they basically carry the community messages onto their local communities. And so we are happy to find speakers either from the RIPE NCC itself or also other community speakers as we are in contact with a lot of people. We sometimes can also provide sponsorship, and obviously we have a lot of expertise and experience in connecting people and helping people to start such NOGs, for instance. And we've recently also set up a mailing list for the NOG organizers. That's the last point on that slide. It's a list that we created basically for the organizers of these groups. Not necessarily for all the participants, but more for the for the program committees or organizing committees, so that they can exchange some information. And it's amazing in how many different shapes and forms these network operators groups come in. I mean, there are some that only meet like a couple of hours in the evening every few months. Others have like 2 full-day meetings with training sessions, everything. And it's really good to see that they're helping each other out in exchanging information, and also exchanging, for instance, potential speakers and content. You can move on, I think. Another project we started a few years ago, and I remember I was actually talking to Jane at the time, because she's involved in a similar project from the Internet Society perspective. It's what we call the RIPE NCC Community Project Fund, and it's basically a way to, we take membership money, so we're based on membership fees of all these over 20,000 members we have, and this is one way of giving back. Giving back to the community of those resources that we don't, or that those fees that we don't necessarily need to cover the costs. So we started this this fund basically, where we have a yearly budget of 250,000 euros, and are funding like 6 to 8 projects depending on on what they need. So it's not like one project gets 250,000, it's like split between a number of projects. And the application deadline is actually open right now until the 1st of September. There's an external committee that evaluates the applications. There's a link there. You can go to that page and submit your proposal. And there are a number of criteria. Basically, it has to be not-for-profit, beneficial for the community. And it tends to be a lot of open source, both software and hardware that we've supported in the last few years. So there were some really good projects that came out of that, or that we managed to that we helped to continue through the project fund. Move on maybe. Another thing we did over the last few years is organize hackathons, and we're also coordinating that with the IETF hackathon. I was meeting with Charles Eckel at the last RIPE meeting, and we basically talked a bit about what works, what doesn't work. It's in a way very similar. I mean, it's free. People can participate. We're organizing 2 hackathons a year. This year, it's the 10th hackathon we're actually organizing on IoT and security. So we don't know quite yet how this is going to pan out, but we're hoping people will come and maybe dissect some devices and see how they can be built better and made more secure. Over the last few years, there were mostly topics like relevant again to operators or researchers, such as measurements and tools and DNS and exchange points, tools for exchange points we had. The last instance was on quantum internet. And out of that also came that quantum research group that's now a part of the IETF in I don't know if they're meeting this week, but you probably know that better. So this next one, again, is open for applications. You can still register. It's in Rotterdam in conjunction with the next RIPE meeting. And also what's on that slide there I wanted to mention is we have a calendar on that page that you can see at the bottom, where other hackathons are also listed if you're interested, and also in other regions if you want to participate. We've been also helping out hackathons in other regions like APNIC and LACNIC and so forth. Move on. Another project we started some years ago already is also, maybe that's why I mentioned this also here, is interesting also for researchers. It's the RIPE Academic Cooperation Initiative, where we're basically allowing researchers, students, academics to come to a RIPE meeting and present their research. And also for this, the deadline or the application is still open till August, so we still have space. At the moment, I think we're looking for candidates for the RIPE meeting in Rotterdam and also for a regional meeting in Kiev, I believe. in October. So go to the website, have a look. I mean, it's a really good opportunity to present your research and to reach out to operators. And it worked really well over the last few years to bring like operational research or operators and researchers closer together. And we saw some really great projects come out of that. And also, obviously, the idea is that those fellows, would be then coming back to the RIPE meetings on their own initiative or maybe funded through other sources. Yeah, that's almost it. One more slide. I think I have just another various other things. I'm also out there presenting and moderating and teaching a lot. And so if you need anyone talking about any of the topics that the RIPE NCC has expertise in or anything I mentioned, please let us know. And then last but not least, I wanted to mention these RIPE Atlas ambassadors that I also mentioned at the beginning, because there's also a really good successful community project. I mean, we almost don't have to do anything with that. There are hundreds of these ambassadors out there handing out these probes. Also the RIRs, the other RIRs help a lot with that. And we couldn't do it without them. So that's a great way that the community helps to bring out what we think is a useful measurements platform. I think that was all. I don't know. I don't think I had a lot more time. I don't know if there are any questions.
You are perfectly on time, Miriam. And the floor is open for about 2 minutes for questions for Miriam. And Miriam, it's just good to see your face. So thank you for joining us.
Thank you.
Does anyone have any questions for RIPE NCC? And if you're not an ambassador for the Atlas program, definitely contact RIPE, because we're seeing the absolutely important amalgamation of data that comes out of RIPE Atlas for some of the work that we're trying to do for more evidence-based research and more information out there in general. Any questions? So go to the microphone. Sorry. If you have questions, you come to the microphone and ask them. And if you can announce who you are and where you're from.
Hi, Miriam. It's Hussein Badran from Internet Society, North American Bureau. I'm really glad that you mentioned the Community Networks program that you have. I wasn't following, this is a new program or you had it for for some time? And if you already had it before, can you share some best practices or some case studies? I think would be very useful for us to take into consideration. Thank you.
You were referring to the Community Project Fund, right?
Yes.
Yes, sorry, just to double check. Yes, I believe this is the 3rd year we're doing this. And yeah, we basically have budget set aside, the board approved and the membership approved. And we have an external committee of experts that evaluate these applications. We have an application form where people have to submit the expected project, lifetime, what the results are, the goals, what kind of budget they're looking for. And it's similar to, what was that called? That ISOC had something similar, I remember. But so we also learned a lot from how you did this in the past. I think maybe the chapter projects I'm referring to, and so it's usually a year-long project, sometimes maybe 2, and then depending on the length of the project, we also ask for like a midterm report, and at the end there's usually like a report either at the RIPE meeting or on the RIPE Labs blog. And what I've seen, and usually these projects, they really trickle nicely in through the community as well. There's a lot of open source, like OpenBGP and security projects that came out of that.
Thank you very much, Miriam. And that does dovetail really nicely with there are some other grant projects that will probably get all that information out on the Gaia list. Well, thank you very much. And we're going to hop over to the team from MLabs. So Miriam, thank you. And we'll have her presentation up. So anyone, it's already on the web. If anybody has any other questions, you can contact Miriam directly. So MLabs team, you are up. Wonderful. Lai, if you can go ahead and introduce yourself, and Chris, and we will help you with the slides.
Great, thank you. Can you hear me all right? Cool. Hi, everyone. My name is Lai Olson. I recently joined Measurement Lab as the project director. myself and Chris Rizzo, our program management and community lead, will be speaking a bit about MLab and how we support the internet research community. Our contact information is here, as well as the link to the slides if you'd like any more information after the presentation. Yeah, great. Next slide. So what is MLab? MLab is made of a few components. We're supported by teams at Code for Science and Society, Google, and Princeton's Planet Lab. We provide a data repository that is, open, contributed by users, longitudinal, and derived from open source internet infrastructure data. And we deploy, build, and run infrastructure that aids in the creation of that data repository. Next slide. Put simply, our mission is to measure the internet, save the data, make it universally accessible and useful. But a note that we like to make is that we don't measure the internet by ourselves. People measure the internet using their own devices and our servers, and we collect what comes from those measurements and make it publicly accessible. Next slide. So all of this is done with our principles in mind. We take privacy seriously, so all of our data is synthetic data, and our measurements are active, meaning only clients initiate tests, servers do not test on their own. The experiments are curated and reviewed by our expert review committee, which are and they're mostly developed by academics. And those measurements come from the community, meaning anyone can develop an edge client and anyone can test against the platform, run tests against the platform. And we believe in openness, so all of our data is released under CC0, and all of our code that we run on the infrastructure is open source. And MLab is a community tool. Our community involves a wide variety of folks who have interest in the internet being measured well and often. And we see academics as a key, and researchers as a key part of this group. And Chris is going to talk a bit more about how it all works and how internet researchers can get more involved.
Super, thanks, Lenny. And thank you for inviting us to present and be involved with IETF. As we move to cover science, we're expanding in our conversations with communities like IETF to make sure that researchers and others understand how to use our data and tools. Go to the next slide, please. So a bit about our platform infrastructure for those who may not already be aware of MLab. We place our servers in transit-connected data centers, so connected to peering locations and internet exchanges, which is a differential in the way that other speed testing and other public internet measurement platforms place servers. So we are not inside of the last mile networks, but we're outside of that. And so then we have some information about routes and performance to locations outside of the last mile. The next slide shows a location where we are around the world. These are different placements of servers where that are running the various tests that we host. And so when a user connects to one of our tests, they get routed to the closest geographical closest server at the moment. And then following into the next couple of slides, talking a bit about the data sets and or the tests that we're running. So tests and experiments we're using synonymously here. And this is a listing from our website of some of the tests that are currently or have been in the past hosted on Measurement Lab. The widest used is, of course, our network diagnostic tool that was originally from Internet 2. And then Paris Traceroute is also used quite heavily by our team as a matter of course. We publish all those data sets in BigQuery. So on to the next slide. So signing up for our Discuss group gives anyone query access for free. And the BigQuery web interface and other locations available to query our BigQuery data sets is how most researchers interact with our data. And on the next slide, we have kind of a listing of examples there. So when you're looking at our tables, we recently renamed our data sets and tables to be more end-to-end specific. So NDT is an NDT data set and so forth. We also publish all of our switch utilization data openly as well, so one can examine the throughput of each location where that collects data. On to the next slide. In terms of accessing our data, there are several ways to do that. We publish our source data, and that's all of basically the raw packet captures and traces and metadata that occur each time a test is conducted to one of our servers. The visualization website, which is an aggregation of our NDT data based on location and by provider. BigQuery, of course, which I just mentioned in the parse data, is the primary way people access our data. And then, of course, there's a variety of other ways to access and or generate data, which I'm going to talk about here in a moment. So we'll just run through these real quick. Next slide. The source data is openly available, and it's stored in compressed TGZ format in Google Cloud Storage. It's primarily used by a small number of researchers and partners. For example, someone recently wanted to calculate actual jitter according to RFC of various tests from a certain geography, as opposed to what the NDT client gives back to the user, which is an estimate of jitter. So to do that, they needed to access and parse through the raw trace files. On the next slide, we publish a visualization website, which on our website, it's the visualizations link in the menu. It is meant to be an accessible front door for the general public to kind of see where they are in the world and see what our data says about their locations and ISPs. And that's updated approximately monthly. And then on the next slide, the primary way, as I mentioned, to access our data is in BigQuery. There's a quick start guide, which gets anyone set up with a Gmail account to query that data for free. A variety of documentation is available, and our support address is here on this slide. This is the primary way we interact with researchers who want to use our data. On to the next slide, please. So because it's a research-focused group, you're interested in what this data can tell you. So we do have a select number of publications. These are both academic and non-academic listed on our website, and I've just pulled a few of them, more recent ones here that are of interest, some of which are coming from researchers in academic units and some which are not, from a variety of fields as well. So we have folks who are doing big data analysis, but we also have folks who are looking at access and cost in the Web Foundation report there. So this is a primary need for researchers. We are an openly available public data set that is available for you to use in your research. Next slide, please. The other way that researchers interact with Measurement Lab is to host an experiment, or a test. So any of the tests that are hosted on our platform are applied by someone who's designed a network measurement experiment, and we're excited that in this calendar year we will complete our migration from a Planet Lab-based system on our servers to Docker and Kubernetes managed platform. And there'll be new opportunities to host new experiments in different contexts. And so if you're a researcher that's developing network measurement experiments, you can apply to host with MLab. And I noted that one new experiment that will be added to the platform is the WeHe app, which is a net neutrality focused test. We're excited about that new platform. And in the next few slides, I'm going to talk about how we currently support researchers. So there's the general support and documentation. So that's the primary way. If you email support, myself or Lai or someone else on the team, we'll get back to you and answer your question. This is a light support and how to get you access to query the data for free or to answer questions as you begin to explore it. We've also begun in more recent in the last year or so, more recently, to do presentations in combination with partners at different research communities. So listed here are some that we've done over the last year or so, which were highly interesting and valuable to make connections with other folks using data. There were some really interesting conversations, for example, with the folks at the Research ICT Africa group at AFRICOM, AFRINIC, and AIS to talk about leveraging multiple types of data sets, for example, using using them in combination. So we've had some conversations about how to use RIPE data and MLab data together. And so those conversations will continue to happen. We've also started to sponsor on a small scale some specific research events and to support hackathons like the SIGCOMM hackathon in Budapest last year. We're going to be sponsoring a sponsor on the Internet Measurement Conference in Amsterdam coming up soon. And so we're excited about engaging with the research community in those events. Next slide, please.
And Chris, just to let you know, you have about 3 minutes.
Okay, I'll wrap it up. Thank you for that time check, Jane. So another way we're supporting research is partnering on a smaller scale on specific research initiatives. So in the US right now, we are a partner on a research program that's focused on US public libraries as an anchor institution to produce a premise-based device that can run our tests automatically and produce a visualized display of that data. Next slide. And community-based research is another area I wanted to highlight separately, because not only are we supporting research on the academic side, but also community-based data gathering initiatives and visualization initiatives. So one recent one is an app that integrates NDT called Test It. And in the US, the National Association of Counties built this app and are using this to gather better geolocation data in order to understand broadband speeds in rural areas. Next slide. And we've participated and supported a number of community-based mapping and surveying initiatives. This one began several years ago with the city of Seattle, Washington, and several other rural counties. The idea being to place a survey and a web-based NDT test in a website that allows users to both answer questions about their broadband speeds and to run a test to gather that data. Next slide. And so we've worked with a number of institutions doing this type of work. This slide showcases the Michigan initiative that is focused on homework gap and giving the test as an assignment to students. Next slide. And this there's another initiative in Louisville, Kentucky that started in Louisville, Kentucky that is now blossoming into a larger initiative from the Technology Association of Oregon. That's at speedupamerica.com. Similar but different technology in the web portal. Next slide. And then finally, we just recently participated in a report with Penn State University under the Center for Rural PA to examine broadband speeds and compare them with our regulators' published speeds from the FCC, and that has recently launched into the next slide, which is a website that New America Foundation recently published that publishes that map online. Really, really interesting initiative there, just looking at the public data sources. And finally, then, coming back to our community slide that we had earlier, this is the real reason why we want to engage with IETF and GAIA and other communities, because we see you, of course, and us as part of the same communities. And so we're looking forward to follow-on initiatives that at MLab that can help involve more people in MLab. And Lai, did you want to comment there at the end about anything related to the upcoming things?
Yeah, also we're really trying to move towards a more community-oriented governance structure and thinking about how we can respond best and provide the best service for the people that are using the measurements and the data. So if you'd like to be involved or hear more about that, we'd really like to hear from you, and specifically the folks in this room.
Thank you both very much. We have about 2 minutes for comments. Does anyone have any comments in the room? If you do, just walk up to the microphone. Okay, I think we thank you very much. There's no one approaching the microphone. Thank you, Lai and Chris. The slides are on the web, so if anybody wants to double check and reach out to the MLabs community, please do. And thank you for what you're doing. We know that the community is appreciative of a lot of the research. And looking at the broadband maps, it always makes me smile, because the next presentation from our colleague Matt Rantanen, who's with the tribal communities, will show us where there are some very big gaps in connectivity in the certain parts of the world. So thank you very much, and Matt's up. We'll pull up your slides. Thank you. Yep. There's a clicker here. Yep.
Stand on the X.
Stand on the X, and there's a clicker if you need it. Yeah. Just tap it.
That was off. Awesome. And the clicker. Okay. So, welcome, Matthew Rantanen. I currently hold the position of Director of Technology for 20 Native American tribes in Southern California. And I've been working with them. I'm starting my 19th year with them. I also run partnering and business development for Arcadian Infracom, which is a fiber builder in the United States. It's about 18 months old. It's been in the public since January. I'll explain a little bit more about that. And then you can see a few of the other things that I've been involved with, currently involved with, and then involved with back in the past. So let's just jump into it since we have 10 minutes or so. So I want to talk about what the previous administration used to call technology deserts. Everybody coins their phrase about the unconnected groups of people in the United States, but this is relevant to where I'm at in the Southwest and where the fiber company is building in the Southwest. So it was a slide that we use, and it's actually on the website of Arcadian's website. So it shows, clearly a infrastructure going to an area with not a lot of people, but it is a way to connect the people. And I just I'll move along till we get into, actually I'm going to go forward and then come backwards. Hang on. So we have land that looks like this in the tribal regions. Now you remember this also in Canada, 634 First Nations. In the US, there's 573 federally recognized tribes. And these tribes were moved to areas where the general population didn't want to live, right? So they pushed people into the base of the mountains. They pushed people away from the beach, away from the lakes, away from where they normally were in habitation. And they were pushed to these regions that didn't have services and didn't have opportunities. So it was the responsibility of the federal governments to be able to connect those people and bring the resources to them because they put them there. And that's not obviously happening. So the tribes themselves have been working to solve this problem. But some of the geography looks like this. And then aerial, you're looking down in valleys that are not visible from other locations except for mountaintops. And can you cue that up a little bit? Yeah. And so this is the kind of solution that makes a lot of sense in tribal communities. I would say one size does not fit all. Every reservation, every tribal reserve is different. Some of them are on the flattest land you can imagine. It looks like somebody ironed it. Some of them are on the most rocky, jagged, geography that's available. And so digging fiber in a lot of situations is not permissible just because geography. Digging fiber is typically not permissible because when we buried people and had cultural ceremonies and things and recorded that was taken away and those records were destroyed. So a lot of where somebody is buried is not recorded. And so when you dig, you typically run into artifacts and different things that are tough to deal with. So you don't want to dig on tribal land unless you really have a good knowledge of what's going on. So a lot of the things, because we are in remote locations and we are away from where the services are delivered, we have to provide our own services as well. So solar power is a big power source, wind power and generator power, a big power source to survive and provide us connectivity at the locations where we need to distribute our network. And yes, it snows in San Diego. I like putting that one up there because San Diego, it's beaches. So we have locations that are very beautiful and very remote. You see below there a homestead on one of the reservations, and how far away it is from other existing infrastructure. And wireless is the way to communicate with those folks. There's some more tower locations that have been built over the years. Really small repeaters to be able to reach out further and further into community. And then I'll get to a map. There we go. Now I can start talking about some of the core problems that have happened. So in the United States, 20 years ago-ish, about 7 networks were built across, east to west, west to east, whatever you want to do. And they were valued on miles built, fiber miles built, right? That was the value of the company. That's where they got their money. They got their loans, their valuation. So to go across the country as fast as you could, building fiber, you avoided things like the Grand Canyon or the Rocky Mountains or, you know, a giant lake. You didn't go through those things because they slowed you down, or you had to go around them to make it easier to build fiber miles. You also avoided Native American reservations. I'm sure it's the same in Canada, but this is the US map. And you see along these paths, this is the fiber paths that exist in the United States. This was done out of, I think, Oregon State University, the map overlays. And I worked with the Obama administration, with the CTO of the United States, to define this very map with the carrier's data, actual KMZ files laid over top of tribal reservation boundaries to determine how many missing middle mile fiber miles there were. There are 8,000 miles of missing middle mile fiber to just connect the lower 48 tribes, and that's 320 reservations. So 8,000 miles are missing just to get middle mile fiber to 320 reservations in the lower 48. Alaska is a whole nother problem. So you see the big red circles, those are what they're calling the connectivity deserts. Those big red circles are full of tribes. They're also full of sparsely populated rural America, small town USA, people that have been left behind. There is no service in these areas. A lot of times, no cellular service. So what do you do to solve that? You can build a community network from the ground up, which we've done at the Tribal Digital Village Network in Southern California. But then our biggest problem was in the last 6 years to try to figure out how to get transport to the rest of the world at an affordable cost, because we didn't have access to fiber. We were paying $99 per megabit per month, US dollars. So obviously you can't scale that and survive. So for the last 6 years, we've been navigating the policy, the state government of California, the different providers in the region, and solving this problem. There's another way to look at this problem and to solve it as well. And that is one of the things that I am involved with the Arcadian Infracom company. So the other way to do it is to take the people who are driving the path of the internet. And who is that, right? Is that AT&T, Verizon, any of the telcos? No. It's no longer the carriers. It is the over-the-top hyperscaler data companies, right? It's Google, Amazon, Microsoft, Facebook, and Apple. Those 5 are driving where fiber needs to be put based on placement of data center. They set a data center down. They need minimum three diverse routes out of that data center to be, within their network plan. They're looking for 4. So if you look at the black lines on the map, those have been built, rebuilt, and people are still building on them. And there's no diversity to those routes. The fiber gets cut in that location. It's all laying in the same ditch. If a backhoe rips open an entire ditch and cuts all the fiber, that whole region's down. If you look at the United States, Denver and El Paso, if you chop out fiber in Denver and El Paso, East does not talk to West until you get it fixed, right? There are no real routes that go back and forth across the US. So it's time to draw new lines on the map. How are we going to do that? We're going to do that with those 5 companies' money to connect their new data centers, because they need another diverse route out of their data center path. But with the ability and the morality to drag that line, that new line on the map, through all of the small towns in the United States, through all of the Indian reservations in the United States, to be able to drop open opportunity at each of those locations, at every intersection, library, post office, you name it. We'll provide opportunity along those routes for our partners and others to come in and build those community networks or muni networks that need to happen to support the small town USA and the small reservations that are spread out across the country. This particular route happens to have 320 miles on the Navajo Indian Reservation. So that is supporting them with strands of dark fiber, lit services, 400 gigs of lit services on the reservation, as well as a revenue share. And that is the new model of how to work with a Native American tribe as a partner rather than as an obstacle when you're moving across the United States and Canada. So then let me flip back up to, I'm going to go backwards for a second. And that one. Okay, cool. So I just wanted to, how much time do I have?
2 minutes.
2 minutes to wrap up. I just wanted to talk about the lack of opportunities in the U.S., the changing environment, that, you know, working with different administrations and things like that really fast. You've seen the landscape, you've seen the fiber map, the data that comes out of the reports from the Federal Communications Commission is skewed because it's based on marketing maps that are provided by carriers, right? Carriers provide what they're proposed to cover and what they cover. If I have a giant area and I have one house connected in that area, that entire area gets counted in that report. So it's false and it doesn't have the true data. So that true data, we're trying to work with the General Accountability Office to define what that true data looks like. We're trying to get the FCC to change their data recording methods, everyone is, to get the reality of that, to be able to define better what it looks like on tribal reservations. Indian communities, Native American communities do not participate typically in surveys. They don't typically want to be counted. Every time they've been counted in the past, they've been eliminated. So every time, how many are you? You're 100. Okay, we're going to kill 50 of you, right? Because you're too many. So there's a stigma there. There's a history there that they don't like to participate in. Every time they get counted, something bad happens. So it needs to be an understanding of, you're being misrepresented. We need to collect the information so that we can understand how to better represent you in this fiber plan and build out plans. So there are some obstacles to education and awareness to be overcome that. We understand that wireless is a great opportunity as a stopgap or as a half measure to get to fiber, and it may be a complete and total solution if the fiber is impossible, but we are striving to get fiber to each of these communities, at least into the community, to be able to have bigger transport and be able to support more throughput to the end user at what we call the first mile, not the last mile. The first mile is the one that counts. And that's pretty much it, if anybody has any questions.
So we have time for some questions for Matt. And we have been trying to promote the idea that the communities are the first mile, not the last mile, because with that sort of mindset, people are thinking to go out to the poorer or the hardest to reach last, which is not cool.
Right.
Question.
This is Dino, listeners.net US. The over-the-top vendors that are trying to bring fiber through, you mentioned that they may have to connect libraries and public places and stuff. Are they resistant to that, or are they just bringing one fiber strand down? It's the responsibility of the individuals to tap into it, or do they not allow it?
So they're not even actually involved in that component of it. So when the build happens from data center to data center, they're just getting delivery from each end. In the middle, we're dragging the line. The company's dragging the line into the region and then offering up connectivity at that location. And then we're not building out the community side. We're partnering with folks that would do that build out. And
they do layer one all the way up to putting switches and routers and stuff. Where does the demarc of responsibility at?
Their demarc, like Google or Facebook's responsibility or ours?
I wanted to know how it all works.
Okay. Okay, so the over-the-top players are just concerned about traffic from A to B and that transport, long haul. And we will be managing loops and small accessibility, huts and handholds along the route to be able to support those communities and be able to give either lit services or strands of fiber to a third party that will be building that component out and managing that. Cool.
All right, thank you. And Matt's here through Friday or
Friday morning I leave. Yeah.
If you have other questions, go for it. Next up is Leonardo versus Leandro Macari, University of Venice, is that correct? Also with the project on the European Commission called the Net Commons Project.
Is this working?
Should be. Oops, no, hang on. That was interesting. Hang on.
Okay.
Echo.
Can you just full screen it?
Yeah.
Cool. Okay. So thank you for having me here. I'm Leonardo. I'm a professor at the University of Venice. Up to May, I was a researcher at the University of Trento in Italy, and I was the work package technical coordinator of a project that is called Net Commons. It ended in 2019, so in March, and we led it at the University of Trento with other partners like UPC. And I'm also a member of the Linux.org community network in Florence, so I'm one of these guys that, climb up roofs and try to make wireless links from one building to another. And just a bit about the project, because I think it could be of high interest for a lot of people that are here. We were researching on community networks under several points of view, on the social side, under the computer engineering side, under the legal side, and there are a lot of results that I suggest you to check out, because we worked a lot and we published a lot about technology, but also about governance, law, and we were able also to influence the law stream in Europe to help community network to grow. So what I'm going to talk about, it's this still unnamed tool, and which I really have to find a name for it, but first we have to make it work properly. And the point is that we were trying to make something that has a double nature. So for communities, so for people like me that go on top of the roofs, we wanted to give a methodology to be able to actually check out if your wireless link is possible or not, and have a rough estimation of how good it is. And then as a research tool, our goal was trying to understand how much a wireless mesh network with point-to-point or point-to-multipoint links can scale, and generate topologies to study how much, what kind of topology we can actually achieve, and possibly in the future where this network may actually evolve in a specific city. Or the components that we use, open data surface models, path loss models, and an engine that simulates the growth of the network. So let me just go through the 3 points. So just a little warning. We did this. The code is already on GitHub. It's a bit done in a rush for a deadline, that's it. But still, we're working on it, and there are a lot of things that we can actually improve. But we're happy to. I'm really happy to receive any kind of feedback. So we started from data sets taken from LiDAR surveys, which are basically, it's a laser technology that is used to map the surface of places, and a lot of public administration give you away this data for free, and you can actually have a 3D view of the city, including the buildings. And then we actually mixed it with data from OpenStreetMap or any other, like this is an Italian public organization that give you the shapes of the buildings, which in some cases, especially in rural areas, it's better detailed than OpenStreetMap. And given these two things, we can actually say if between a couple of buildings there is line of sight, and then we do some heuristic and to understand if the Fresnel zone is partially obstructed. And with this, we kind of estimate the path loss that you can have between those two buildings. And once you have this is just an example. This is Florence. It's a city in Italy. We're starting with data from Italy because we know the language, how to interpret the things. And and this is the pink is ground level, white it's buildings, and this is a hill that is just on top, in front of my house specifically. And this is the same thing from under the 3D point of view. So those the mountains here, there are the buildings, the thing on top over there, it says the hill, and then we just we just impose on top of those hills the buildings, and then we are able to understand modeling if think it's possible. And well, the result is more or less this kind of stuff. This is just an example of a link that can be done. This was on this was in Lyon, because Lyon has a very nice, in France, has a very nice data set with a lot of precision. And basically this is the same link that we were testing using different kind of data sets. The first one is the most precise one. The second one is a downsample. And the third one is, it's a pretty famous, pretty used database that is called SRTM, that you can get it for free from the NASA. It's for all over the world, but its precision, it's really different from what we need in urban areas. And so we extended this using the data sheets from Ubiquiti devices. Ubiquiti, it's a vendor for wireless stuff, right? Wireless gears. So we collected data from a few of those gears. And so given the path loss, we can actually try to understand what would be the bit rate that those two specific devices could actually negotiate. And since we know the price of these devices, we can also estimate what is the best couple of devices to make that specific link. And this is something that we are still working on. So it's just a very simple web interface where basically you actually pick 2 points in space. You choose how tall your pole where you can mount your devices will be, and you pick the devices, and this is going to tell you if there is line of sight, and it's going to give you a rough estimation of the bit rate that's going to be negotiated, depending on a lot of heuristics that I'm not going to go through here. So now we have a way to estimate if a link is possible, and we were discussing at the Battle Mesh in Paris with other communities, other wireless communities, how the way that they could use it, and there were other communities that were doing similar stuff using different data. So they had quite a good reception from them. But then we try, on the research point of view, we try to make some to use it to estimate how a growth, how such network could grow in various environments, urban, suburban, rural. And so basically what we do is we decide the location of a gateway, like in a city, and then we pick a random sequence of buildings in the area, and every time we try to connect those buildings to those that are already in the network. And for each, every time that we add a new node, we try to estimate what is the guaranteed bandwidth that this new node will have towards the gateway, or the other way around, actually. And again, there are a lot of heuristics here that I'm not going through, but okay, this more or less, it's a model, then we can improve, but it's a model. So in the end, what we can do is to have this network that grows, picking nodes at random and telling us what is the bandwidth that every node could get. And then we have to decide when this growth will stop. One way to estimate this is that we actually fix a certain minimum bandwidth per node, and we actually measure what is the percentage of nodes that actually achieve this minimum bandwidth. And then we stop when there is no way to add new nodes without making all the network, without breaking the stop condition, which is 95% of nodes will have at least a specific bandwidth that we decide. And this, again, a lot of parameters, but it's something that we can actually work on. And so what is one of the goals of this research? For instance, when you do mesh networks, you cannot plan your network. Nodes pop up, new people want to join, and they just join in where the house is. So what you can do, you can actually give them suggestion on how to shape the network while it is growing. So for instance, one thing that we want to know if there are local-only decisions that we can actually try to enforce to make the network more scalable. For instance, you're adding a new node, which means that this node will potentially connect to several other existing nodes. Which is the node that you're going to choose? And the normal decision, the dumbest decision that we have always taken as community networkers is you just pick the one that is giving you the best bandwidth on that link, which is it's just the most natural thing that you do. actually, we were imagining if we can do something better than that. For instance, since we have a metric that is going to determine when the growth will stop, well, you could actually pick the neighbor that is actually producing the metric that is better for the network. So the neighbor that will actually give you the best metric in your network evolution. And this is just one of the things that we can do. Okay, I have some numbers here, but I don't want to go much into the details. What I want to show you here is that you have a different minimum bandwidth per user, and this is the number of users that you can achieve, number of nodes that you can achieve with respecting that stopping condition in various urban environments. These are all topologies that we generated using data from the Tuscany region, because yeah, we know it. And this is with a greedy approach. So you get between 150 and 200 nodes for the minimum bandwidth for 1 megabit per second. And if you use the network aware approach, you can more than double it, basically. So if you give the instrument to the community and they have to make this decision, you can actually help them to make the network scalable, or well, scale better. And yeah, that's more or less everything. So we did this tool to model the growth of the network, and the methodology can actually replicate it using data from any place. And we are giving away the code, and we are also trying to understand if you can include data sets from other countries so that people can just use our servers, which are not actually not public now, but they're going to be. And yeah, and then we have a lot of ideas to keep developing this tool in several directions. Just a few things is one thing. Now we're picking nodes at random. It would be really nice if we could actually pick nodes with some other criteria. So we could take data from national surveys and understand who is living in that building, more or less, because data are pretty detailed. And so you can understand, well, in average, you have people with this education, this age, and so they might be more likely to want this link. And if you get this kind of data, then you can actually try to understand where your network evolves, not just as a random topology, but in that specific city, where is it going to go? So which area in that city are going to be served or are not going to be served? And that's it. Credits, code by myself, Gabriele Gemmi, bad code by myself, a good code by Gabriele, and Daniela made the interface. And then you find a lot of details in this paper, which was actually accepted a few days ago. So you find it on the Ad Hoc Networks Journal, and I'm going to put for sure a version online on my webpage. And this is also together with Leandro. And that's it.
Any questions for Leonardo? And don't forget to introduce yourself.
Hi, Curtis Imro. Where do you get those LiDAR maps?
Where do I get the LiDAR maps? From public administrations, like in Tuscany, there's a website that gives you the LiDAR map. In France, I think that huge part of the nation is covered by LiDAR map, and you can get them. Some of them are also even integrated in OpenStreetMap in some places. So, but this, for instance, in the guys from New York, they have the whole, not the LiDAR map, they have the whole 3D model of the whole city. So they do something similar.
So the guys from New York are the New York City mesh guys who are deploying mesh networks on the top of rooftops in Brooklyn and other places. And they were at Battle Mesh. So they've got a GitHub site. We can put you in touch with them because they're super keen to work with other community networks as well. Any other questions? One more?
Hi, Joseph Pontanix, Algorithms Foundation. Are you getting any pushback from other suppliers when mesh networks are being deployed? Are the incumbents pushing back at all?
I don't think I got the question. If you're having any...
Step closer to the microphone.
Oh, maybe I'll bring it up. Are you getting any pushback from any incumbent suppliers? Like even if they're not servicing certain areas, are incumbents seeing potential competition and getting in the way either directly or through various jurisdictional administrations?
So you asking if in general, or what's the relationship between like community networks and telcos and...
So here in Canada, some mesh network companies are having quite a problem with companies I won't name, but and the jurisdiction administrations tend to have their closer alliances with certain big companies. So I'm wondering if you're experiencing the same sort of thing in Italy.
Well, that's a good question, and I mean, I can answer you on the basis of the project that we did, where we were talking with many different communities, and it depends a lot on the place. For instance, in Italy, it's actually illegal right now to do trunking on 5 gigahertz, so on ISM bandwidth, which should already kill the whole thing itself, something that we discovered 6 months ago. In other places, there is like small operators actually behave well with community networks. In other situations, big operators do not go to that place as long as the community doesn't show that there is a market, and then they come there. But it really depends on the specific situation, so I cannot generalize.
Thank you very much, Leonardo. And Leonardo's here through what day?
Friday again.
Through Friday. Great. So Curtis, you're up. And to the gentleman that just asked the question, some of us have targets on our backs because of this. There is a lot of pushback around the world for the small networks, which is really strange to us because there are small community networks servicing communities of 5,000 and under generally, where the return on investment for the bigger companies isn't met. So we don't quite understand why the model isn't accepted. So it's a conversation we could have perhaps outside the room so that we can make sure Curtis gets up there. But it's a complicated conversation, just to put it diplomatically, I guess.
Yeah, just so I'll be happy to speak with anyone outside here on that. It's an issue that affects not just this domain, but lots of domains. So.
Cool, thank you. So Curtis, introduce yourself.
Yeah, hi everybody. I'm Curtis Emerald. I'm an assistant professor at the University of Washington. The purpose of this talk is a little bit of grenade throwing in a light, very happy, supportive way. So this is a really early stage project that we're just spinning up in Seattle. And what I'd like to do is be told it's a bad idea if it's a bad idea. And hopefully it's a good idea. And maybe that's what we'll get out of this. So yes, hello, I'm Curtis. I'm part of the ICTD lab at the University of Washington. This is a long-running research lab focused on the intersection between technology and poverty. Professor Richard Anderson is the other co-lead of the lab. He runs financial services and health services, and I do universal internet access and conservation. So my lab for quite a while now has been working on community networking, and we've already talking about this. So a brief introduction, just in case some people didn't haven't been following this for a while. These are networks built, owned, and operated by the citizens and users in a participatory and open manner. GUIFI being the juggernaut in the space at 35,000 nodes, just this like amazing effort in Catalonia. But there's many, many of these networks now. Freifunk, Altermundi, NYC Mesh, all these sort of networks spinning up throughout the world. They're all built on these 802.11 mesh protocols, which we're hearing a little bit about there. And there's a whole bunch of reasons for this. It lets you operate an unlicensed spectrum. Largely, we're at the IETF. We understand IP networks. These are IP networks, and so we're able to use these in sort of an intuitive way. My group in particular has been working on a subset of community networks known as community cellular networks. These are community networks utilizing the cellular protocols rather than the Wi-Fi protocols. We build off of some open implementations of the cellular standards, OpenBTS and Osmocom for the 2G stuff, Open Air Interface, SRS LTE for the LTE stuff. There's a couple examples of these networks, many, many less than the 802.11 networks. Rhizomatica being the juggernaut in this space down in Oaxaca. Our own networks in the Philippines and Indonesia similarly. My group has recently, not that recently, probably the last couple of years, transitioned over to focusing on LTE, specifically a project called Community LTE or COLTE, which Spencer right there runs. And so we've been deploying that into our communities. Recently, there's a network up in Oaxaca. I have a student there right now, as well as a network up in Indonesia, and hopefully we'll be scaling from there. These networks have largely focused on sort of traditional rural access problems, stuff like what Matt was talking about. Just saying, hey, there are areas without connectivity, cellular is a good fit for that, right? And then we come up with normal rural access problems. Hey, you don't have backhaul, let's do local services, all of these kind of things. But our group has sort of been iterating a little bit, and we started asking ourselves the following question. is community cellular appropriate for cities as well, right? So you look at our work on community cellular, it's all rural, but you look at mesh networks, things like NYC Mesh, you don't get a lot less rural than New York City. And so we were trying to see if maybe this technology could be applicable in that domain as well. And so I'll go through a little thought experiment on Wi-Fi networks versus cellular networks. So the biggest Wi-Fi network I can find in the world is a thing called FAWN. Has anyone in the room used FAWN? 0. Okay, wait, 1. It's reported as 23 million hotspots throughout primarily Europe, which is probably why it's a little bit of an unfair question to ask here. Distributed around. And the idea is basically similar to your Xfinity Wi-Fi at home, right? So the way FAWN works is they put their software onto a router, you run the router, and by being a FAWN customer, you can roam onto other FAWN routers in your town, right? And so this is, I think, the largest Wi-Fi network on Earth. This is what FAWN coverage looks like in downtown London. So 23 million hotspots, but you can kind of see some of the limitations of trying to build city-scale Wi-Fi networks, right? And so there's a whole bunch of these. First, Wi-Fi is just bad at city scale. You can see all these little dots are little dots. And that's the nature of Wi-Fi, right? Wi-Fi has been selected to operate in these bands that have low propagation. And so it doesn't go very far. Wi-Fi is really bad at mobility. It was just never designed into the protocol. Mobility being the ability to move between different access points. So you'll lose your connection and you lose everything as you go along. This is solved by some of the centralized Wi-Fi stuff, but you don't see that that commonly. And again, the limited coverage area makes it just hard, right? You're going to run into a dead spot pretty fast leaving your house, even if handover worked. And lastly, Wi-Fi is bad at spectrum coordination. We see this with the mesh network work. If the network is really, really dense, no communication happens. If the network is really, really sparse, you lose connectivity between the hops. So it's really hard to build these kind of city-scale Wi-Fi solutions. And now we'll give an example of a city-scale cellular solution. This is British Telecom. This is British Telecom's map of London. The green areas are areas with good coverage. It's all of them. It's the river. It's everything, right? And so why is this easier? Well, there's a lot of business reasons, which I'm at the IETF, so I'm going to punt on those. It's actually a little unfair to punt on those because that's a whole side discussion, but we're community networking people, so we can punt on this in the short term. Cellular is really good at wide area, right? It's designed for this. It's kilometers of coverage, and that's what it was built for in the start. Cellular is great at mobility. It's a level 2 element of cellular. It's like a core requirement. The 2G standard was built specifically to allow people to move on trains in France. Like that was in the specification to be able to do that. LTE actually includes peer-to-peer mobility primitives in the protocol. So the eNode Bs, the access points, talk directly to each other to do mobility. And lastly, it's good at spectrum coordination. This is literally what cellular means. Cellular is spectrum coordination. It's how to coordinate spectrum inside of a city so we don't waste any of it. And then there's all these technologies that sit on top of that. SONs, self-organizing networks, being the sort of standard to be able to coordinate spectrum. So, cellular networks are good for city-scale coverage. Okay, this shouldn't have been too much of an argument with anyone. Why? What's stopping us, community networking people, from building this stuff? Well, there's sort of standard set of answers to this problem. Spectrum, right? Cellular loses licensed spectrum, and licensed spectrum is brutally difficult. Well, it turns out that's been shifting. It's been shifting quite a bit recently. First, we have the CBRS band. This is the Citizens Broadband Radio System, band 48 LTE. That is a neat tri-level licensing regime that has frequency open for small users. Like you don't have to be a telecom to get that. In fact, there are always bands available everywhere for non-telecom users. So that's great. And moreover, the cellular people are creeping in on our business. And so now that there's actual cellular protocols to run in Wi-Fi bands, this is LTE-U and LTE-LAA. Those are designed to coordinate with the existing Wi-Fi installations to allow LTE to operate there. So cellular spectrum is getting a lot easier and has in the last 5 years. Okay, cellular hardware is super expensive, right? Well, not since LTE. 2G access points were like tens of thousands of dollars 10 years ago. There's been a big drive to commoditize those, and so now 2G access points are $5K, and LTE eNode B that you can run, that we run in Papua, is $2,500. And new radio, 5G, is pushing that even farther. So they've built a commoditization model into there that's making this all much more affordable as we go forward. As we mentioned, telecoms are kind of difficult to work with. And so, well, what are we going to do? We need telecoms, right? No, LTE is IP-based entirely. It's just a big Wi-Fi network. And so do what you do in your Wi-Fi network, run things over the top, run WhatsApp, and you're running a wide area network without the telecoms necessarily being able to get into your way. You don't need phone numbers. And lastly, cellular equipment is really hard to use. And this is actually, I think, the most exciting one, and sort of brought me into this room to talk about this, is that, you know, LTE isn't designed for the little guys, right? Everyone in here can run a Wi-Fi hotspot, but you can't do that with LTE necessarily. This is shifting right now. One data point is the wireless ISP model in the US. There are hundreds of wireless ISPs in rural America running LTE equipment. They do that, they hand you the radio receiver, and it has a SIM card built in, and you just have access in the wide area. So this is already happening. So sort of hacker-ish folks are running these networks at scale in the US. The second thing that's happening is private LTE, and this is all IoT buzz, but it's actually getting built. So these are, let's say you own a factory and you want to do IoT in your factory. Well, what you can do is install a small cell phone network just in your building. Again, smaller and smaller organizations participating in building out these kind of networks. Lastly, carrier aggregation is, I think, the most exciting thing. This is going to be a huge element of the middle term future and into new radio. What it is in buildings like this, the owner can install LTE in the building. And what they'll do is they'll loan that out to the carriers, the MNOs. And charge a little bit of overhead on that. So basically every office building, every residential metropolis building is going to have a building-owned network in it. And for that to be a community network is not significantly different than what it is now. You just pointed at a different carrier aggregator. Okay, so this is kind of the point. I think this is a great opportunity right now to start to build out community LTE in cities. Oh, I went too fast. So, what's the plan? What are we doing? What are my students actually building? It's largely this, right? So our technology agenda is a thing we're calling federated LTE. And the big idea is we're using distributed ledger as the backend to store a whole bunch of the core network required. People know Amber. We've sort of hedged our bets on doing Amber-esque stuff, but thinking LTE is the better access medium for all the reasons I've given earlier. The big idea here is make it so that anybody can join this federation, right? You stand up a new LTE network, you point it at the right thing, you join the federation, all the SIM cards work, all the roaming works, all that kind of stuff. And instead of just doing the billing as the federated element, which is what Amber did before, we're going to try to do everything LTE. So authentication, mobility, and spectrum coordination, similarly in the sky in a way that everybody can peer together in a distributed, decentralized fashion. So this isn't a hugely technical talk, so I'm going to hand wave all of that, but we are building things and we're deploying things. And so this is our planned deployment here in the fall in Seattle. So we have access to 2 rooftops from the University of Washington. One is Harborview Medical, and the other one is 4545 in the U District. And so that's the northern one here, and this other one here. We're going to put 2 networks up, have them federate together, and build a small-scale federated LTE network in Seattle. I think it'll be the first community cellular installation in a city that I know of. A key point here, and kind of one of the reasons to be here, is that as a nature of a federated network, anyone here is welcome to join, and we'd be happy to point you on how to do this kind of stuff. You stand it up, and we'll send you some SIM cards, and you can roam onto our network, and we can roam onto yours, and hopefully everybody will be friendly and happy. All right, thanks.
Excellent. Any questions for Curtis? We have about 2 minutes.
This is Jeffrey Yaskin.
Hi.
I wanted to ask about privacy. So,
Yes.
The state of privacy on telecoms is pretty awful, but
Yes.
a user has kind of an entity to look at a privacy policy for.
Sort of,
with,
yeah.
With community cellular and kind of building cellular, like how does that work? How does that negotiation work?
So the way that it works technically is that your radio will connect to whatever the core network is somewhere, right? And that's the organization you're talking about that has some sort of privacy guarantees. And so even in the roaming network and like your a carrier aggregation side of a building, if you're an AT&T customer, they'll build a pipe for you to go to AT&T, and then your data is ostensibly private, at least to AT&T. Now in our system, we're actually removing a whole bunch of this for a bunch of technical reasons, just saying we should be doing what the internet does and do end-to-end privacy on basically everything. It's only handling IP traffic. If you're sending me unencrypted things over that, it's not going to help you, or it's not going to be a good idea. But yeah.
Peter Hessler with Clio Connect. What sort of backhaul requirements do you have for the other nodes? Like if I were to spin one up in Berlin, Germany, for example, What do I need to provide?
Sure. So traditionally, backhaul limitations have been a huge deal in rural access, specifically for LTE. Our network in Papua has a 3 megabit per second backhaul. Our front haul connection on that thing, like front haul is the wrong word, but the connection to the user is at like 100 megabits. And so the mismatch there is a huge deal. The nice thing about what we're doing here is the city of Seattle in particular has fiber all over the place. So we're just plugging into that. We're going to be good to go. So in general, the answer is like approximately 100 megabits, slightly more than that, but it depends on the use. An individual handset, I think, can handle like 20 megabits per second normally, and then you're going to spread out your 100 megabits over whatever. But so that's probably about the right answer.
IPv4, IPv6, multicast?
These are great questions. I don't know off the top of my head. Yeah. It depends on what our open source partners currently support, which almost certainly means IPv4 only.
This is Dino, listeners.net. In the private LTE building case,
yeah.
Is that a deployment where you would use it instead of Wi-Fi or in addition to?
It's mostly, so in addition is the sort of reality facing version of it, right? So if you have an apartment building, people are going to put in their own Wi-Fi. But what they want to do is have like the people coming into the building have cellular the whole way through, and they've built this whole business pipeline to be able to get that money out of AT&T and into the building owners. And I think in the future, this is a longer discussion. I think there's like a big battle to be had of exactly the question you're asking, because why would you run both of these at the same time? And I think the reality is that LTE has a lot of really nice properties, but at the moment, it's going to be both for a while.
The motivation of my question is, do you think, is there a requirement, or have you solved or thought about roaming between public LTE, private LTE, and Wi-Fi and Wi-Fi 6 and all these different radio technologies that are going to exist at the same time?
Yeah, I mean, the
IP addresses are going to be changing for each one. The
MNOs have thought a lot about this. They have a solution set for this, and the idea is that if everything is AT&T, it works.
Right, all on network.
Yeah.
But what about the community networks, which is not going to be the case?
See, we should talk about it offline, because I have a whole bunch of like fun, thin SIM, hacky solutions to solve some of these things. At the end of the day, hopefully what it'll be is the federation is another element of the MNOs you can connect to. So if you have a federated SIM, you're able to roam onto that network and participate in the same way. But
have some solutions for you too.
Yeah.
Okay, cool. We have about a minute, so if we can do speed round now.
Cool. Hey, Curtis, we're going to probably solve this over beer later, but how much of this is pirated cellular or spectrum?
So hopefully zero. Yeah, those days we don't speak of anymore in general. So, but yes, we're hoping to use CBRS in Seattle. Like that's the story, and we're sticking to it.
What is the current process in the US to get the authorization to do an experiment like yours? How did you get it?
So the band 48, the CBRS band, is currently has a set of nationwide licenses that have been doled out. So we have a partner who's going to let us use that. In April, it's going to roll over to the actual SAS, the spectrum, not auction system, maybe an allocation system, which does sort of an automated system of grabbing spectrum, in which case we're going to be deploying a thing that lets us do that so that we grab the spectrum as it goes. There's like nice technical stuff for CBRS at the moment, and largely the discussions have been about rural areas, but the fact is there will be spectrum available in cities, and so that's what we're trying to leverage.
Awesome, thank you so much. And we do, no, sorry, maybe you guys
you can grab me afterwards. Okay, thanks.
Cool. And how long are you here? All week?
I'm here till Friday morning too.
Awesome. Okay, sorry, Mallory. I'm going to turn it over to Leandro to close, because he has some ideas on what our next steps are and a process we'd like to initiate on a doc.
Yeah, very briefly. My presentation, I skipped it for the next time. It was related to the challenge of revising there is an RFC that was produced by this group in 2016. It's called Alternative Networks Models or something like that. And then there was a discussion about technologies at the time, alternative models of network providers, and definitely things have changed significantly in the last few years. So just say that if you're interested to contribute, if you have some ideas about things that could be updated, extended, replaced, or whatever, just come to me or send me a message, and then we will try to organize a plan in the next meeting about how to upgrade the document, how to keep it up to date. And well, I think it's now 1 minute to 3. So thank you so much for everyone, like those who gave very interesting ideas, those who had questions, those who have some things to discuss after the meeting, and well, I hope you enjoyed the meeting, and I hope the information is useful for the presenters. If you go to the pad, you can also correct or extend your description of your presentation, and then we will publish the notes in a week or two.
Yeah, and if you haven't signed the blue sheets, please do. And thank you very much. We appreciate your time. And the folks here are still going to be here through about Friday. So if you've had other questions, there is the bar and there's coffee. Thank you very much. I really love the